In this video, you will learn how to convert decimal numbers and fractions in base 10 to any required base. There are two methods that I will be showing you on how to convert decimals and fractions in base 10 to any required base, and I will be illustrating the two methods with the following examples. Example 1. Change the following as indicated. 0.75 base 10 convert to base 2. Method 1. In the first method, we will have to change the decimal number into fraction because the decimal works only with fraction. So let's go ahead and change this decimal number into fraction by moving the decimal point 2 steps to the right. That will give us 75 over 100. The next step will be to simplify this fraction to its lowest form. 5 in 75 is 15. 5 in 100 is 20. 5 in 15 is 3. 5 in 20 is 4. Therefore, 0.75 base 10 is equivalent to 3 over 4 in fraction. The next step will be to express this numerator as a multiple of the base we are converting into. Now, since we are converting into base 2, we will express this numerator as a multiple of base 2. Now, let's look at the multiples of 2. 2 times 1 is 2. 2 is a multiple of 2. 2 times 2 is 4. 4 is another multiple of 2. 2 times 3 is 6. These are all multiples of 2. However, the closest to 3 is 2. Therefore, 3 can be broken into 2 plus 1 over 4. Again, we'll split this sum into 2 over 4 plus 1 over 4. And then now we'll simplify this fraction. 2 in 2 is 1. 2 in 4 is 2. This will give us 1 over 2 plus 1 over 4. The next step now will be to express these denominators in base 2. So 2 in base 2 is the same as 2 to the power of 1. 4 in base 2 is the same as 2 to the power of 2. Therefore, 1 over 2 is the same as 1 over 2 to the power of 1 plus 1 over 4 is the same as 2 to the power of 2. Recall again from the law of negative index that x to the power of minus m will give 1 over x to the power of m. In other words, the minus here changes to 1 over. We can as well change this back from the fractional form back to the index form by changing the 1 over back to minus in front of the m. Now, if we apply that concept here, it means that the 1 over here will change into minus in front of this 1. Therefore, we have 2 to the power of minus 1 plus 1 over here will also change to minus in front of these 2. Therefore, we have 2 to the power of minus 2. Now, this expression is the same as 1 times 2 to the power of minus 1 plus 1 times 2 to the power of minus 2. Now, these whole number digits form the answer for the decimal part. Therefore, 0.75 base 10 is equal to the whole number part is 0. So 0 base 10 is the same as 0 in base 2. Therefore, we have 0. Why the 75.75 in base 10 will now be replaced with 1 base 2. That's 1 base 2. 75 base 10, 0.75 base 10 is equal to 0.11 base 2. This is our answer for 0.75 base 10 when converted into base 2. Now for the second method. While the first method works with fraction, the second method works with decimal. Therefore, our 0.75 in decimal will not be converted because the second method works with decimal. However, to execute the process using the second method, what we do is to multiply the decimal number by the base we are converting into. We are to convert this to base 2. Therefore, base 2 will be used to multiply this number, and we record the whole number in each case. Now let's do that. 2 times 5 will give us 10. We write 0 and carry 1. 2 times 7 will give us 14 plus 1, that is 15. We write 5 and carry 1. 2 times 0 is 0 plus 1, that will be 1.50. Now instead of writing the 1 here, we'll push the 1 aside. The whole number is here, the whole number here rather will form our answer. So we push the 1 over to the left and replace here with 0. We repeat the multiplication process again. 2 times 0, 0. 2 times 5 is 10, carry 1. 2 times 0 is 0 plus 1. Again we have 1.00. Instead of 1, we push the 1 out again and replace here with 0. Now the whole multiplication process will end the moment we get to 0, 0, 0. Therefore, our answer will be 1, 1 in base 2. However, please take note, for this method, you write the answer from the top to the bottom. Therefore, by the second method, 0.75 base 10 is equal to 0 base 10 is the same as 0 in base 2 point. Then 75 base 10 is now 1, 1 in base 2, 1, 1 base 2. Now if you look at, you see that the answer for the second method is the same as the answer for the first method. Example 2. Here we are to change 9 whole number 16 over 25 base 10 to base 5. The first thing to do here is to change the whole number base 10 separately and also change the fractional part separately. So 9 base 10, we'll change that to base 5. How do we do that? We'll use 5 to divide the 9 and take note of our remainder in each line of division. 5 divide 9, that's 1, remainder 4. 5 divide 1 is 0, remainder 1. Therefore, 9 base 10 will be equal to, we write the answer to this from the bottom to the top, that's 1, 4 base 5. Now that will be the answer for the whole number part. We now move to the fractional part. Now for the fractional part, we can use both methods, the first method and the second method. Now to use the first method, the first thing we'll do is to break this numerator into multiples of the base. The base is 5, so we break 16 into multiples of base of 5. Now let's check the multiples of 5. We have 5 times 1, that is 5. 5 times 2, that is 10. 5 times 3, that is 15. 5 times 4, that is 20. These are all multiples of 5. However, the closest to 16 is 15. So 16 over 25 can be broken down into 15, then plus 1. Divided by 25. The next step will be to separate the two sums. So we will have 15 over 25 plus 1 over 25. Now simplify this fraction. 5 in 15 is 3. 5 in 25 is 5. This will give us 3 over 5 plus 1 over 25. Now in the next step, we will express the denominator of this fraction in base 5. So 5 in base 5 is the same as 5 to the power of 1. 25 in base 5 is the same as 5 to the power of 2. Therefore, this 3 over 5 is the same thing as 3 over 5 to the power of 1 plus 1 over 25 is the same as 5 to the power of 2. Now the next step will be to separate the numerator and write the numerator of each. So for the first term, this 3 over 5 to the power of 1 can be written as 3 times 1 over 5 to the power of 1, because 3 times 1 is the same as the 3 we have here. then plus this also can be written as 1 times 1 over 5 to the power of 2. Now this will now give us, if we write these fractions now in index form, remember again that x to the power of minus m is equal to 1 over x to the power of m, which means that 1 over is the same thing as x to the power of minus. If we turn this 1 over x to the power of m, if we turn this 1 over back to minus in front of this m, we have x to the power of negative m. The same thing here, 1 over here, we'll return it back to minus, or we change it back to minus. The minus will be in front of this power 1. Therefore, we're going to have 3 times 5 to the power of negative 1 plus 1 times, again here, 1 over will be changed to minus. So we have 5 to the power of negative 2. Now, these 3 and this 1 will be combined together to form our answer for the fractional part. Therefore, 9 whole number 16 over 25 base 10 will be equal to, we write the answer first for the whole number part. For the whole number part, the answer is 1 4, then point. For the fractional part, the answer is these 3 and this 1 combined together. That will be 3 1 base 5. Therefore, 9 whole number 16 over 25 is equal to 414.31 base 5. Example 3. 574.235 base 10. We are required to convert this to base 5. Now, again, we have a whole number part. The whole number part is 574 base 10. We will convert this separately. 0.235. The decimal part will also be converted separately. Now let's begin first by converting the whole number part. That's 574 divided by 5. 5 in 5 is 1. 5 in 7 is 1. Remainder 2. 5 in 24 is 4. 5 times 4 is 20. Remainder 4. 5 again. 5 in 11 is 2. 5 times 2 is 10. 11 minus 10 is 1. 5 in 14 will give us 2. Remainder 4. 5 here again. 5 in 22. That will give us 4. Remainder 2. 5 in 4 now will give us 0. 5 in 4 is impossible. That's 0. Now, since this 4 was not divided, we'll move the 4 over to this side as our final remainder. So 574 base 10 when converted into base 5 is going to be 4244. 4244. So let's take note of that. So 574 base 10 is equal to 4244. This is the answer for the whole number part. Now come to the decimal part. Now let's see if the first method will work for this decimal part. Remember that the first method only works with fraction. So the first thing to do will be to change this decimal into fraction by moving the decimal point 3 steps to the right, and that will give us 235 over 1000. Now if we divide this, 5 in 23, that is 4, remainder 3. 5 in 35, that will give us 7, so we have 47. 5 in 1000, that's 200. Now if you look at this denominator, this 200 that we have here is not a multiple, is not a base 5 number. 200 cannot be expressed in base 5. Therefore, the first method cannot work here. So we cannot use the first method to convert the decimal part into base 5. So we now go ahead and use the second method, since this first method will not work. And for the second method, remember, the second method works with decimal. However, the process is to multiply the decimal by the base you want to convert into. So since we are to convert this into base 5, we will multiply it by 5. 5 times 5 is 25. We write 5 and carry 2. 5 times 3 is 15 plus 2, that is 17, carry 1. 5 times 2 is 10 plus 1, that's 11, carry 1. 5 times 0 is 0 plus 1, that will be 1 0.175, but this one whole number will be pushed out, so we have 1, and here will be replaced with 0 since we have moved the whole number out. We repeat the process again by multiplying by the base again. 5 times 5 is 25, we write 5 and carry 2. 5 times 7 is 35 plus 2, that's 37, we carry 3. 5 times 1 is 5 plus 3, that is 8. 5 times 0 is 0. Point. Again, the whole number digit here is 0, we push it out. 0, if we move the 0, we will still have 0 here, so we'll multiply again by 5. 5 times 5 is 25, that is 5 raised to power 2. 5 times 7 is 35 plus 2, that is 5 times 8 is 40 plus 3, that's 43, we write 3, we carry 4. 5 times 0 is 0, then 4. This will be 4 points, but the 4 here, the 4 whole number here, we move it out again and replace here with 0. Now we repeat the process again, that will be times 5. 5 times 5 again is 25, carry 2. 5 times 7 is 5 plus 2, that's 37, carry 3. 5 times 3 is 15 plus 3, that is 18, carry 1. 5 times 0 is 0 plus 1, that will be 1 point. So the one whole number, we move it out again and replace here with 0. So we have 0.875. Now, if you look at the process, you see that there's repeating pattern here. Because at this step, we have 0.875. At this point, we also have 0.875. Which means so instead of continuing, is a repeating decimal or a recurring decimal. I can terminate the process here. Therefore, the whole numbers here will now be combined together to form the answer for the decimal part. The answer for the whole number is 4244. The answer for the decimal part is 1041. Writing from the top to the bottom, 1041. Now combine the answer for the whole number part, that's 574.235 base 10. If we combine the answer for the whole number part, the answer is 4244. Point. The answer for the decimal part, which is 1041, then dot dot dot. This dot 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 indicates that the process has not ended. Thus there are still several other digits after this one. So 4244.1041 base 5. Why don't you go ahead now and try these exercises, number 1 and number 2. For number 1, you have to change to base 3. For number 2, you have to change to base 7. Remember to post your answers in the comment section below. Thank you and see you in the next video.